Hello, I am Flash Isaac, and today we shall be solving Jamb physics likely questions. During the era of Jamb PPT, paper and pen, Jamb sets questions from physics, around 60 questions, and in different paper types, type A, B, C, D, and so on, while in some years, the paper types are in colors red, blue, and yellow. And since the introduction of Jamb CBT, computer-based testing, Jamb sets thousands of questions across all subjects. Now, out of those questions that are shuffled, in your own hall or in your computer, you have access to 40 physics questions. And it can change depending on what Jamb wants. In that case, the questions you are answering are not the same as the one your neighbors or those around are answering. And discussing with friends, you will discover that there is a lot of differences in questions. While with some candidates, there may be little similarities. You need to study very hard and smart for Jamb and cover as many areas as possible. We asked a lot of persons, what did they set? What are the questions you can still remember? They will just tell you, okay, they set this, we can still remember that. This is the question. So from those questions and from Jamb syllabus and also past questions, I've been able to get a lot of questions, likely questions. This is why you need to follow this video series. This is the part 1 of likely physics questions. I will release videos for mathematics, chemistry, and many other subjects. Depending on the time you are watching this video, all the questions would have been solved and released. So simply go through the playlist and search for any one of your choice or visit flashlearners.com. Now, let us see questions and detailed solutions. The units of moment of a couple is measured in dash. First, what is couple? A couple is two parallel and equal forces that act in opposite direction. You can have forces acting in opposite direction, parallel and equal forces. Now, the moment of a couple is simply one of the forces of a couple times distance. So the moment is equals force times distance. Now, force is measured in Newton. And distance is measured in meter. This means the unit of moment of a couple is simply Newton times meter, which is equals Newton meter. And that is option A. Newton meter is correct. Let's take a look at the next question. Which of the following quantities have the same unit as the watt? Which of the following quantities have the same unit as the watt? Now, when you see watt, something comes to mind. Power. The unit of power is watt. And what is power? Power is equals work over time. It is the time rate of doing work. If you are able to do work in a shorter time, it means you have much power. And if you are doing the work in a bigger time or more time, you have less power. The lesser the time, the more the power. And the more the time, the lesser the power. What is work? Work or work done is the product of a body's force and distance. So work is force times distance. This means power is equals force times distance all over time. This is another formula for power. And power is also force is mass times acceleration. which is ma distance s over t. This is power. It is also equals mass mgh over t, where g is acceleration due to gravity. So for downward movement or for bodies falling freely under gravity, acceleration due to gravity adds instead of linear acceleration. And the value of gravity is approximately 9.8 meter per second squared, or you can use 10 meter per second squared. And distance, this is horizontal distance. But for bodies falling freely, or when we are dealing with a vertical distance, we no longer use distance, we use height. This means s changes to h. Now look at this. From power equals force times distance over time. Take a look at something. What is this? This is distance over time. And what is distance over time? It is simply velocity. Velocity is change in displacement, which is distance, all over time. This means power is also equals force times velocity. Option A, force times time. No. This is impulse. Option B, force times distance. No. This is work done. Force times acceleration, and option E, force times velocity. Correct. So, which of the following quantities have the same unit as the watt? It is simply force times velocity. Now, let's take a look at the next question. Which of the following is the dimension of pressure? Dimension of pressure. In physics, we have fundamental quantities and we have derived quantities. Fundamental quantities are independent on other quantities. They don't depend on other quantities to exist. And the top three are length, mass, and time. We have other fundamental quantities like amount of substance, temperature, distance. Quantities that are derived or derived quantities, they get their units and they are gotten from fundamental quantities. For example, force is a derived quantity. And what is force? Force is simply mass times acceleration. What is mass? Fundamental quantity. And what is acceleration? Acceleration is velocity over time. And what is velocity? Displacement over time. So, you see, they all come from fundamental quantities. And these fundamental quantities, they have their dimension. The dimension for length is L, mass is m, and time is t. Now, they are asking us, what is the dimension of pressure out of all this? The first question you should ask yourself is, what is pressure? Pressure, P, is equals force over area. A force is acting. You ask, what area is this force covering? That is the pressure. We also have pressure in liquids, and it is a detailed topic in physics as well. If pressure is force over area, what is force? Force is mass times acceleration. And what is area? Area is length times length. L squared, that is area. Length times length. And the unit of area is meter squared. For other shapes, we have formulas for their areas. For example, in a triangle, the area is half base times height. In a square, it is length squared. In a rectangle, it is length times breadth, depending on the shape. But in any of the shape you use, area is simply the product of two lengths. That is it. And what is mass? Mass is m. This is the dimension m. What is acceleration? Now, Acceleration is velocity over time. What is velocity? Displacement over time. Displacement over time. So everything becomes over time. This is simply displacement over time divided by time. This is displacement over time times 1 over 10. We just change division to multiplication. Anytime you change division to multiplication, the number after it inverts. For example, if I say 1 over 2 divided by 3 over 4. To change this division to multiplication, the number after it will invert. You simply say 1 over 2 times 4 over 3 instead of 3 over 4 to give you 4 over 6. So that is it. So we have d over t times t is t squared. That is distance over time squared. And what is distance? Distance speaks of length. Area covered. So distance is length. Length and time is t, L over t squared. That is the dimension for acceleration. So L t raised to the power of 2. L over t squared is the same thing as st raised to the power of minus 2 rather. And this is distance. L times L, L squared. From this, L squared cancels one of the L, leaving L behind. So we simply have mass L raised to the power of minus 1 because it is under t raised to the power of minus 2, or m over L t squared. This is the dimension for pressure. Now let's look at the option. M L raised to the power of minus 1, t raised to the power of minus 2. The correct option is option A. We found the dimension of pressure. Now let's see the next question. What is the height of the liquid column in a barometer tube that would support an atmospheric pressure of 102,000 Newton per meter squared if the density of the liquid is 2,600 kilogram per meter cube? This is a pressure question. To solve question under pressure, take note that pressure is equals rho GH. What is rho? This is density. This is acceleration due to gravity, and this is height. We are told that the height of the liquid column is missing. We have to find the height. Remember, the atmospheric pressure is 102,000 Newton per meter squared. And the density of the liquid is kilogram per meter cube. This is in meter, this is in meter, and acceleration due to gravity is in meters. So we have everything we need. From here, divide both sides by rho g. This cancels this. So height equals pressure over density times gravity. And this is equals 102,123 Newton per meter square all over density 2,600 kilogram per meter cube times acceleration due to gravity 10 meter per second. That will simply give you 3.92 meters. A metal block of mass M is equals 2.5 kilogram was heated from 20 degrees Celsius to 80 degrees Celsius. This is initial temperature. Let's call that theta 1 is equals 20 degrees Celsius. Then theta 2, the new temperature, is equals 80 degrees Celsius. If the first temperature is 20 degrees Celsius and the second one is 80 degrees Celsius, change in temperature will simply be equals 80 degrees Celsius minus 20 degrees Celsius, which is equals 60 degrees Celsius. In 30 minutes, so time is equals 30 minutes, and that is equals 30 times 60 seconds equals 1800 seconds. So we solve using time in seconds. And it says using 120 watt heater. A heater was used and the power of the heater in question is 120 watts. So P is equals 120 watts. Calculate the specific heat capacity of the metal, assuming no heat losses. Remember, P is equals MC change in theta. H is equals MC change in theta. H is equals power times time. So H is equals H, meaning power times time is equals M, specific heat capacity, times change in temperature. That is simply, since we are looking for C, C is equals power times time over mass times change in temperature, which is equals 120 watts times 1800 seconds over a mass 2.5 times change in temperature 60. To convert to Kelvin, it is simply 60 degrees plus 273. So this will give you in Kelvin plus 273 Kelvin. Which of the following is not a vector quantity? In physics, we have vector quantities and we have scalar quantities. Vector quantities are quantities that, when we are describing, we describe the magnitude and we describe the direction. Magnitude plus direction. While in scalar quantity, they have magnitude, which is just size, and we are not concerned about the direction. For example, if I ask you what is the distance or what is the height, you tell me 20 meters. But if a force is acting on a body, 20 Newton, you are free to ask, in what direction is this force acting? Is it towards the north, south, west, east? Is it acting downwards or upwards? So in vector quantities, they are represented with arrow. After the size, you need to show us the direction. And in bearing, we have magnitude and we have direction. These are vector quantities. Now give me these options. Which is not a vector quantity? Meaning, which of the following only have size and no direction? A. Force. Force is a vector quantity. Weight is a vector quantity. In fact, weight is mass times acceleration due to gravity. It is a force as well, downward force. Meanwhile, altitude is just a distance or height. It has size and doesn't have direction. It is the only scalar quantity here. It is scalar and not vector. So we will choose option B as the correct option. Now this question says, starting from rest, a car of mass 1000 kg accelerates steadily to 2 meters per second in 10 seconds. The average power developed in this period is dash. The task is to solve for the average power developed by the car. Now let's look at the parameters. It says starting from rest. Whenever a question tells you that a body starts from rest, this means initial velocity is equals 0. Starting from rest is an indirect way of telling you that the initial velocity of the body, of the car, or of the object is equals 0, which means it accelerates steadily or uniformly. A car of mass, so M is equals 1000 kg. So velocity is 2 meters per second and time is equals 10 seconds. Power is the question. What is power? Power is the time rate of doing work, and there are many formulas for solving for power. For example, power is equals energy over time. Power is equals work done over time. And work done is the product of force times distance over time. Power is equals MAS over time, and it's also mgh over time under gravity. And energy can be kinetic or potential energy. A car starts from rest, accelerates steadily. This means the energy possessed by the car is not the energy due to position or height. It is the energy due to motion. And the energy due to motion is simply kinetic energy. And what is kinetic energy? It is half mv square, and since it is over time, over t. Do we have mass? Yes. Do we have velocity? Yes. And do we have time? Yes. So we have all the parameters we need to solve this question. Half 1 over 2 times 1000 times 10 square all over v square is times 2 square all over 10. We can simplify here. Half of 1000 is 500. So 500 times 2 squared is 4 times 4 over 10. This cancels this, so this is 50 times 4. 5 times 4 or 4 times 5 is 20. So this is equals 200. 200 watts divided by 1000 is equals 0.2 kilowatt. 200 watts or 0.2 kilowatts is correct. Option A is the correct option. This is how you attempt questions like this. The distance moved by a particle in the 6th and 8th seconds of motion are 45 meters and 53 meters respectively. Determine the acceleration and initial speed. The acceleration A and initial speed value. The distance moved by a particle in the 6th and 8th seconds of motion. From Newton's law of motion, the first law states that a body at rest will continue to be at rest, and if in motion, will continue in that state of motion until it is acted upon by a force. That is the law of inertia. And the second law states that the rate of momentum, the rate of change of momentum of a body, is proportional to the force applied and takes place in the direction of the force. And that is the law of momentum. From the second law, you get impulse to be changed in momentum. And the third law states that for every action, there is an equal or opposite reaction. Now, there are equations of motion. And anytime you are given questions under motion, there are equations you must follow to solve these questions. The first one is V is equals U plus AT. And S is equals UT plus half AT square. V square is equals U square plus 2AS. Now, since we are dealing with a distance moved, let's consider this second equation. But that is not the major problem now. It says the distance moved by a particle in the 6th and 8th seconds of motion. 6th second, 45 meters, and 8th second, 53 meter. The car starts moving from here. Here, it started from rest. It started moving. 1, 2, 3, 4, 5, 6. 6 seconds. Then it moved 8 seconds. Now, they told others in the 6th second, it moved 45 meters. There is a difference between in the 6 seconds and for 6 seconds. If a body moves for 6 seconds, it means we are concerned about the total distance. But in this case, it says the 6th second. This means from here to here to here to here, that 6th second, the 6th one, that is what we are concerned about. This means we are concerned about this distance covered in 6 seconds minus the one covered in 5 seconds. If a body covers 20 meters in 5 seconds and 25 meters in 6 seconds, this means in the 5th second, in the 6th second, the body covers 25 minus 20. That is the distance in the 6th second. This is what we are concerned about. The distance covered in the 6th second is simply the distance covered in 6 seconds minus distance covered in 5 seconds. That will simply be when t is equals 6 and when t is equals 5. We simply subtract them like I did. So distance s is equals ut plus 1 over 2 at squared minus ut plus 1 over 2 at squared. This one is distance covered in 6 seconds. This one is the distance covered in 5 seconds. So subtracting them, we get the distance covered in the 6th second, which is equals 45 meters. So this distance is 45 meters and it's equals ut. Time here is 6 seconds. So 6u plus 6 square over 2a minus the 5th second, 5u plus 5 square over 2a. This is the distance covered in the 6th second. Similarly, the distance covered in the 8th seconds of motion is 53 meters. The distance 53 meters is equals the distance for 8 seconds. 8u, we are replacing t with 8 plus 8 square, that is t square, we bring it here. 8 squared over 2a minus, here is for the 7th seconds, 7u plus 7 square over 2a. So this is the distance covered in the 6th second and this is the distance covered in the 8th second. Simplifying this, we'll have from here, let's simplify. 45 is equals 6u plus 36 divided by 2 is 18. 18a. We are using this minus to open up this bracket. That will give you minus 5u minus times plus another minus 25 over 2a. This 53 is equals 8u plus 64 over 2, that is 32a, minus times 7u is minus 7u, minus times plus 7 square over 2, that is minus 49 over 2a. So this simply means we have 6u minus 5u, 18a minus 25 over 2a, 8u minus 7u, 32 minus 49 over 2a. Solving simultaneously, equation 2 minus equation 1, this will obviously cancel. So subtracting this and subtracting this from this, you will get that a is equals 4 and u is equals 23. Option C is the correct option. Now let's take a look at this set of questions. The first one says the bond between silicon and germanium is dash. Silicon and germanium. The two best known semiconductors are silicon and germanium. In physics, we have conductors, semiconductors, and insulators. Conductors are materials that allow the passage of current easily. They have low resistance. Example, copper and silver. These are examples. Insulators, they do not allow the passage of current or electricity at all. Examples are cover of wire. If you hold a wire, it won't shock you because it has been insulated. Plastics, they don't allow the flow of current through them. While semiconductors they have conductivity in between that of metal or conductor and that of insulator. They are in between. Semiconductors, they conduct electricity when impurities have been added to them. When you add impurities to a semiconductor, it begins to conduct, and the process is called doping. You can choose to add a trivalent impurity or pentavalent impurities. Semiconductors are tetravalent. They have 3 electrons in their outermost shell. So you can call these holes. They are tetravalent. Now, when you add a material that is trivalent, trivalent means the material has 3 electrons in the outermost shell. So, given these 4 holes, 1 electron fits here, 1 fits here, 1 fits here, we have more holes than electrons. In that case, we formed a p-type semiconductor. And if we are doping with pentavalent impurity, an element with 5 electrons in the outermost shell, the 4th one fits here, then the extra electron will be here. In this case, we have more electrons than holes. Electrons are negative charge carriers, while holes are positive charge carriers. So when you have a pentavalent impurity to dope, you form an n-type semiconductor. N-type. Now, the bond between semiconductors is covalent bonding, sharing of electrons. That is the bond between semiconductors. In metals, electrovalent bonding is dominant because metals easily donate electrons between metal and non-metals. We've answered that type of question. Diode is a rectifier. Transistor functions as a switch and as amplifier. These are the 2 main functions of transistors. While capacitor is a charge storer. That answers this question. Then the next question says natural radioactivity consists of the emission of dash A. Alpha particle and beta rays, C. Alpha particles and S3, C is alpha particles, beta particles and gamma rays, and D. Gamma rays and S rays. Radioactivity is the spontaneous disintegration of the nucleus of an atom or element to emit radiation and forming smaller nucleus. We have 2 types of radioactivity: natural radioactivity and artificial radioactivity. Some unstable atoms or unstable elements or unstable nucleus, they can disintegrate to form smaller ones, which are formation of alpha particles, which is a helium nucleus, beta particles, fast moving electrons, and gamma rays. That is natural radioactivity. Meanwhile, in artificial radioactivity, a stable nucleus or nuclear is bombarded with heavy water, that is deuterium, bombarded with alpha particles, beta particles, and fast moving electrons to make them unstable and disintegrate. From Darcy's atomic theory An atom can neither be created nor destroyed. But in radioactivity and other nuclear physics, atom can actually disintegrate to give you energy and other radiations. And this question is asking us to find the frequency of light. The beam of light has a wavelength of 600 nanometer. 600 nanometer. This is the same thing as 600 times 10 raised to the power of minus 9 meters, which is 6 times 10 raised to the power of minus 2 of 2 times 10 raised to the power of minus 9 meter. That is equals 6. This is something as 0.6 times 10 raised to the power of 3 times 10 raised to the power of minus 9 meter, which is equals 0.6 times 10 raised to the power of minus 6 meters. So that is the wavelength. And the speed of light is 3 times 10 raised to the power of 8 meter per second. Remember, the velocity v is equals f lambda. So frequency is equals the speed of light over wavelength, which is 0.6 times 10 to the power of minus 6. This is the frequency. In an atom, if the number of proton is equals the number of neutron, the atom is said to be electrically neutral. And for this, we are given a capacitor. These two are in parallel. This capacitor is in series with these other two, and these other two are in parallel. So we resolve capacitors in parallel, then we resolve those two together. So this and this in parallel, we resolve them to be in series with the 6 microfarad. So the equivalent capacitance, let's look for this and this. In parallel, to solve for capacitors in parallel, you simply add them. So in parallel, this and this will simply be the total equivalent capacitance is C1 plus C2. That is 5 plus 7. And this is equals 12 microfarad. The 12 microfarad, this becomes 12 microfarad in series with 6 microfarad. So this is the new capacitors. We simply look for the equivalent capacitance, which is 1 over C equivalent or C total is equals 1 over 6 plus 1 over 12. This is how we solve capacitors in series. And it's the opposite of resistance. Okay, we are going to resistors. For example, these resistors are in parallel. To solve the equivalent resistor or the equivalent resistance in parallel, we simply say 1 over R equivalent is equals 1 over 2 plus 1 over 3 plus 1 over 4 in parallel. But in parallel, you add capacitors. And in series, you divide capacitors. Meanwhile, resistors in series, you solve them like capacitors in parallel. 1 over C equivalent is equals, the LCM is 12. 12 divided by 6 is 2. 2 times 1, 2. Plus 12 divided by 12 is 1. 1 times 1 is 1. This is equals 3 over 12. 1 over C equivalent is equals 3 over 12. C equivalent is equals 12 over 3 microfarad. Then this, the LCM is 12. 1 over R equivalent is equals 12. 6 plus 4 plus 3. This will give you 13 over 12. In this, 1 over R equivalent is equals 13 over 12 ohm. R equivalent is equals 12 over 13 ohms. So voltage V is equals I, 13 times R times 12 over 13 ohms. This cancels this. So the equivalent voltage is equals 12 ohms. We've gotten the equivalent voltage 12 volts, equivalent resistance 12 over 13 ohms. The current in the 3 ohm resistor, this particular one, will simply be the equivalent voltage because the same voltage flows through them in parallel, which is 12 over current flowing here over 3. In parallel connection, the same voltage flows but different current flows across them. To give you current is 12 over 3 ampere. And this last question says, which mode of heat transfer cannot be explained by molecular theory? It is simply radiation because it doesn't require a material medium. But conduction deals with vibration of the body. There is particle movement, so molecule is involved. Radiation, molecule of water. Even expansion, the molecules collide, making a body to expand. Wow! With this, we've been able to touch some likely Jamb questions for you. This is the part 1. Trust me, the part 2 is going to be amazing. Don't forget to subscribe to this channel to get more videos and other topics. Go through Flash Learner's YouTube channel, flashlearner.com. You will find a lot of things very, very helpful to your exam. Success in your exam.